Okay, so let's continue 5.2. We can also find the interest rate when it's unknown. To do this, we're going to have to use some of our skills. So let's see what happens. Find the annual interest rate given the following information. A is 10,000, P is 9,000, T is 5 years, N is annually. So we've got 10,000 equals 9,000 times 1 plus our unknown R over N. In this case, N is 1. So 1 times 5 power. So this is 10,000 equals 9,000 times 1 plus R to the 5th. Divide by 9,000. 10,000 over 9,000 will reduce to 10/9. It's 1 plus R to the 5th. To get this unlocked, I'm going to have to take the 5th root of 10/9. So 10/9, the 5th root of that means 1.02 equals 1 plus R. 1.02, we need to go really about 4 decimal places, so don't round to 2 decimal places if you're doing this, because remember, when we turn it into a percent, it's going to get 2 more decimal places after that, so I would always go 4 decimal places. So 1.0213 equals 1 plus R, subtract the 1, so 0.0213 is R. Turning that into a percent is 2.13% is R. So even though you might think that, hey, if I need 2 decimal places, I'm going to round to 2 decimal places here, if it's turning into a percent, you always need to go 4 decimal places so that there's still 2 decimal places on the percent when you are done. And I'll leave number 2 for you to practice that on. So inflation, as a concept, is the amount of average, the price level that increases per year. It's usually somewhere in the 2%, near the 2%. So with an annual inflation rate of 2.5%, how much did an item that cost $2,000 today cost 11 years ago? So right now, it has a future value, which is really current, of $2,000. But what did it cost 11 years ago with our rate of 2.5%? Where N is 1 all the time. Let's see. So if I simplify this is 2,000 equals P times 1 plus 0.025 all to the 11th, or 1.025 to the 11th. So this is what I'll divide by. So the price level is 2,000 divided by 1.025 to the 11th. So let's see what that is. Is approximately $1,524.29. So you can see that in 11 years, just generally from price level increases, the price of things will go up. It's roughly something that was $1.50, would cost $2 now, etc. How long will it take the average price level to double if the economy has an overall annual inflation rate of 3.7%, round to this nearest integer? Okay, so the idea of the price level doubling, you can just choose a random price, current value and future value, but the easiest way to do it is 2 equals 1 plus R to the T. The reason for that is it doesn't matter what price you choose. You know the price level doubling, that if it became $2,000, it was at $1,000. If it became $5, it was $250 before. And when you divide those out, it always will go down to 2 because the price level is doubling. So in this case, our rate is 1.037 to the T. This is where our skills from the last chapter will help us. I can rewrite this in logarithmic form, or I can just take the log of both sides. Now, if I rewrite this in log form, log base 1.037 of 2 equals T. But to put this in the calculator, I really need the log of 2 over the log of 1.037. To see how often the price level doubles at a 3.07 or 3.7% interest rate. Log 2 divided by log of 1.037 is 19.08 years. So a little over 19 years, the price level doubles, which means that if we had an inflation rate of that in about 19 years, so in 2039, that something that costs $5 now would cost $10 then. Something that costs $1,000 now would cost $2,000 then. So that's how inflation problems work. Okay, so some word problems. Mr. Lee has $7,000 to invest. One wishes. He has two options. Option A is 6% compounded daily. Option A is 6.2% compounded yearly. After 10 years, how much would be in each account? And which one should he choose? Let's assume Mr. Lee likes money, so he'll choose the one with more money. So let's look at that. We've got option A is future P, so we have 7,000. 1 plus R over N, so 1 plus 0.06 over 365 to the 365 times 10, because it's 10 years in either case. Option B, we have a different N and a different rate, so it's 1 plus 0.062 over 1 to the 1 times 10, because N is 1, because it's compounded just yearly. And then we would check both of these in the calculator and get the actual value. So we got 7,000 times 1 plus 0.06 over 365 to the 365 times 10. This one has $12,754.20. Ooh, I'm rich. This other one, 1 plus 0.062 over 1 to the 10th power is $12,774.48. And so it's really weird. You would think that this is barely a larger interest rate, 6 to 6.2%, and compounding daily would be worth so much more than just compounding once a year. But the truth is the rate gets cut into such small pieces that it doesn't actually make as big a difference, which means option B is actually better. Okay, so one thing to note for a problem like number 4 is that the total amount you pay when you borrow is the original plus the interest. So if you find the future value, you can take the future value, so that means your interest is your pay, how much you end up paying at the end, minus your original. So I want to leave that one for you guys to calculate, but I do feel like reminding you of that is important. Actually, we may just calculate it in the next video as well.